Hello, Luke. Welcome to Lesson 36. So today we'll be talking about the distributive property of rational expressions, and then we'll be just reviewing really some concepts of some minus signs and negative exponents. All right, so the first thing, distributive property of rational expressions, sounds complicated, but it's really not. This should be a pretty easy lesson today. So just a reminder, what is a rational? What's a rational expression? Rational expressions basically is a fancy way of referring to fractions. So any fraction would be considered a rational expression. So all of these would be rational expressions. So whenever you see that word rational, just think of fraction. All right, you can really use those two interchangeably. So when we talk about the distributive property of rational expressions, well, it just means we're using rational expressions in the distributive property. So if I have something that were to look like this, for example, 3/4 times, A over B plus C over D, something like this. All right, and I told you to expand this. Well, remember, expand implies that we need to use the distributive property. So if we're expanding it, we need to multiply this 3/4 by the first term and then multiply it again by the second term, right? That should be all review. So if we take this 3/4 and multiply it by the AB, and then we're adding that to this 3/4 multiplied by the CD, right? Just distributing that 3/4 through. 3/4 times the first term plus 3/4 times the second term, okay? So now really the new part here is dealing with these rational expressions here. If I have a rational expression such as 3/4 times AB, how do I multiply that? And the answer is very simple. It's the same way that you'd multiply any fraction that dealt with numbers. So if I had something that looked like 1/2 times 3/4, how would you multiply this? Well, you'd multiply it by starting in the numerator. 1 times 3 is 3, and then go to the denominator. 2 times 4 is 8, and we'd end up with 3/8. Okay? Same thing applies here. It's just now we have some variables in here, but that's all right. We know how to multiply variables. So in the numerator, we have 3 times A. Well, that's just a 3A, right? And then in the denominator, we have 4 times B. Well, that's simply 4B, right? And there we go. We're done. Okay? So the same rules that we would use when multiplying fractions with numbers, we would also use in fractions that have variables. It's as simple as that. All right? So here, down on this problem, if I have 3/4 times AB, well, we already discovered that that's 3A over 4B. And then I have my addition, my plus sign, and now I have this multiplication to do. So I have 3 times C, which is 3C, over 4 times D, which is 4D. And so there I would have my expansion for this expression, right? Using the distributive property. It's as simple as that. So maybe let's just try a couple examples, and I'll pull one right from the book here. So if I have something that looks like x squared over y squared, and I'm multiplying that by the expression x squared over y minus 3y to the third over m. Okay, and again, I'm asking you to expand this or use the distributive property. We will start by taking this outside term and distribute it through to the first term. So we have the x squared over the y squared times this x squared over y. Right? And that's just simply taking this term and multiplying it by the first term. Then we can take our next term. We take this guy and multiply it by this guy. Now this is a positive. This is a negative. So when I multiply a positive by a negative, I'm going to end up with a negative. right? So we'll just put that right here. We know it's going to be a negative. Then we have the x squared, again, the outside term, x squared over y squared times the inside term, which is the 3y to the third over m. Okay, so that's our two multiplications that we'll be doing here. Now we can multiply this out. So if I have, well, we'll go back to the orange, x squared over y squared times x squared over y, we can just multiply the numerator. So what's an x squared times an x squared? When we're multiplying like variables, we add the exponents. So it's x to the fourth, right? And then over what's y squared times y? Well, that's y to the third. And then we have our minus sign. And now we have an x squared times 3y to the third. Well, that's going to be a 3x squared y to the third, right? And then in the denominator, I have a y squared times n. If I put that in alphabetical order, we'll write it as m times y squared, right? Very good. Now, you might always check at this point just to make sure there isn't any simplifying that you could do. And in this case, there actually is, all right? So we could recognize that, okay, in this first term, x to the fourth over y to the third, there isn't any simplifying we can do. But in this second term, we might notice that there are y's in the numerator and there are y's in the denominator, right? And we've done this before. That means because this is all multiplication in the numerator and multiplication in the denominator, we have some common factors in the numerator and denominator. So what could we cross out? Well, we can say that this y squared is going to cross out two of these y's upstairs here. So we're left with just one y, right? The y squared can remove two of these y's, okay? So we end up with, we'll just rewrite this x to the fourth, y to the third, minus 3x squared y, because it's still y to the 1, over, this y is gone now, it's just a 1, and m times 1 is just m, so we have over an m, all right? That would be our solution. Now, you may have thought about this before, and it's all right if you would have done this simplification earlier too. So if we would have gone back, if we go back up to this term here, where we're actually multiplying these two out, instead of just multiplying them, we might think about cross-canceling first. And you remember what cross-canceling is. If I have 3/4 and I'm multiplying that by, 8/16, let's say, we could say, oh, well, this 4 can go into itself once, 4 can go into 8 twice, and then we multiply it out, right? And that's something that can be done here as well. So looking at these fractions, we may have been able to recognize that, okay, we could cross-cancel out these y's. We have this y to the squared here. That could cross out this y to the third and make it into a y to the 1, right? We're losing two y's. So if we would have done that, this would have become a 1. And then we would have had x squared times 3y, which is just x squared, or 3, I should say, 3x squared y, right? And then we could have in the denominator just the 1 times the m, which is just an m. And of course, this is negative still. And there's our second term that we got down here, right? So we could have cross-canceled in the multiplication process here, or we could have cross-canceled at the end and just looked for any common factors in the numerator and the denominator and factored those out then, or canceled those out then, all right? So hopefully that makes sense. Either way is acceptable, all right? Let's try another one here. All right, so let's try this one. So again, we're going to be multiplying things through. We will distribute this to the first term. So we have m over z times axp over mk. And then we have our positive outside being multiplied by this negative term. That's going to give us a negative. Don't lose track of that. And then we have to think of this second term as a fraction, because we're multiplying a fraction by, you might say, a whole number, I guess. But let's think of it in terms of a rational number, as a fraction. So let's just put this over a 1, All right. Then we can clearly see what's the numerator and what's the denominator. So we have m over z times 2m to the fourth p to the fourth over 1. Okay? And then we can just kind of start multiplying these out. So I'll start this one by just looking for anything that I can cross cancel. And in this case, I have an m here which could cross cancel with this m there, right? So we'll just do that right away. Save ourselves a little multiplying here. Then in the numerator, we have axp over the denominator, which would be z times k, right? And if we look at that, there's nothing else that can be simplified. And then over on this other term, we know we're going to end up with a minus. And is there anything to cross cancel here? Well, in this case, there is not, right? So we can start multiplying through. So m times this 2m to the fourth p to the fourth is going to give us a 2m to the fifth p to the fourth over z times 1, which is just z. All right? And there we go. We're done. There's nothing left in this term that we can do, nothing left in this term that we could do. That would be our solution. All right. Let's try another one. All right, so why don't you try this on a separate sheet of paper, and then we'll try it together. All right, so let's multiply this through, and maybe we'll try to do a little bit more of this in our head here, because that's kind of the goal here. So if we have ab over c squared times this first term, well, let's multiply the numerators right away here. So ab xab is going to be ab, it's going to be a squared, right, b squared x. All right, and then in the denominator, we have c squared times c. That's going to be c cubed. All right, we're going to have a plus, and then ab times this numerator, we're going to end up with a 2a squared b to the third x over c squared times c squared c to the fourth minus ab times the 4ab. Well, that's going to be 4a squared b squared over c squared times the c to the fourth is going to be c to the sixth. And there we go. And then maybe now we'll just go through these terms and look for any canceling that we can do. Any reducing, you might say. So in this first term, nope, there's nothing in here. There's no common factors. In the second term, there isn't any common factors between the numerator and the denominator. And in the third term, there's nothing we can do. So that is our final answer. And look at that. We did most of it in our head. All right, and then moving on to our second part of the lesson today, we're going to be just reviewing a couple of concepts dealing with negative numbers and negative exponents. Really, this should be an easy review, but it's just a reminder to not get these things mixed up. They want to make sure that you have them straight in your head. So I'm going to throw a couple of things down here, and I want you to try them on your own, and then we'll do them together. Hopefully these will come easily to you. There really isn't anything new here. All right. So why don't you pause the video and just give these a try. All I want you to do is to simplify them, and we'll see how you do. All right. So let's see what you came up with. This first one should be very, very simple, right? 4 squared, well, that's just 4 times 4, which is 16. Very straightforward. This next one is just a little bit different. We have these parentheses, and we have this power of 2 and this negative sign. And the tendency might be, well, we won't talk about the tendency. Let's just see how you did. So if you have a negative 4, the parentheses are what we're squaring here. That's what's being raised to the second power. So we're raising everything inside these parentheses to the second power, including this negative sign. So this would be the equivalent of a negative 4 times a negative 4, which is a negative times a negative is a positive. So we end up with a positive 16, right? So negative 4 squared is a positive 16. Okay, now let's go to this next one. Here we have 4 to the negative 2, and remember to simplify negative exponents, we need to move the number with the exponent onto the other side of the rational number. So this would be the equivalent of 4 to the negative 2 over a 1 if we forced this into a fraction mode. And now we can move this 4 to the negative 2 onto the other side of the fraction bar, which changes the sign of the exponent, right? And since we're moving that down and there's nothing left on top, there's just then a 1 on top. And we move that down, it becomes 4 to the second, right? The sign changes in the exponent when we move it to the other side of the fraction bar. Watch out, the sign for the coefficient, the 4 in this case, does not change. That stays the same. The sign that changes is the one that's in the exponent. All right, so we have 1 over 4 squared, which is going to be equivalent to 1 over 4 times 4, which is 16. So that would be our answer there. All right, now this next one is really why they wanted to review these, because these are the ones that can be a bit trickier. So looking at this one, we have negative 4 raised to the negative 2. Maybe the first step is just to eliminate the negative exponent. All right, so if we do that, we move this down into the denominator, and we end up with 1 over a negative 4. That doesn't change, but the 2 does. That changes to a positive 2. Okay, so now we got rid of our negative exponent. So the next thing would be to try to simplify this. And the question that you might ask, is this a negative 4 times a negative 4? Or is this a 4 times a 4? Okay, do I include the negative sign with this 4? And we've talked about this in the past. And remember, the exponent has kind of a short reach. It only affects the number that's directly below it. So it only affects this 4, okay? It does not affect the sign. The only time the sign is affected is when the exponent is over a parenthesis, such as this one over here. Here, the exponent is affecting this parenthesis. Well, that parenthesis, that's a container, right? We talked about this before. Think of it as like a bucket, right? So it's affecting the bucket, which means that everything inside the bucket has to be raised to the second power, including, in this case, the negative sign. But over here, we don't have any bucket. It's just affecting this 4. That's it, okay? Nothing else. And that would be similar to this one. It's only affecting this 4. All right, so this becomes 1 over the negative. We don't do anything to it. It stays right where it is. The 4 squared would be a 16. So we end up with 1 over a negative 16. You could also write that as a negative 1 over 16. Either way is correct. So I'll even circle both of these. Either one of those is an acceptable way to write negative 1/16 or 1 over negative 16. Okay, so hopefully that is clear to you and that you won't make that mistake, and hopefully you haven't been up to this point. But remember, this exponent only affects the number that's right below it, or in some cases the parenthesis that's right below it, which would then include everything inside that set of parentheses. Okay? All right, so this next one falls under the same rule. So we have negative 4 raised to the second power. The 2 is only going to affect the 4. And so therefore, the negative sign doesn't change, and we end up with 16. 4 times 4. All right. Here, we have this negative 2. So let's start by getting rid of the negatives. That's usually the best place to start, is just get rid of the negatives. The negative exponents, that is. So to do that, we flip this expression into the denominator, and we're going to end up with a negative 4 raised to not the negative 2 now, but the positive 2. Right? And now to simplify that, we look at this 2, this exponent, and ask what is being raised to the second power? It's the parenthesis, right? The bucket. So everything in the bucket has to be raised to the second power. So a negative 4 raised to this negative 4 in the parentheses raised to the second power, it's equal to a negative 4, that bucket, being multiplied by the bucket again. So it's a negative 4 times a negative 4, which in this case is going to be a positive 16. So here we did use the negative sign when we multiplied it by itself twice. So up here we did not. The only difference between these two is the set of parentheses, right? That's key. So you have to recognize that this negative 4 in parentheses raised to a 2 is a positive 16 because it's a negative times a negative. Up here, it's only the 4 that's being raised to the 2. So it's a 16, and then we tack on this negative sign. It's a negative 16. Okay? So these two really are the ones that, give people the most problems. This one and this one. You have to understand the difference between those two and why you simplify them the way that you do. All right? Very good. So I think we will stop here for today. And again, generally, it's mostly just review, just recognizing how to multiply fractions with variables in them. And it's just a reminder on how to simplify negative exponents and negative numbers. All right, very good. Then we will stop, and I will see you tomorrow.